Putting an approval gate on every single tool call doesn't build a safer system. It just builds a slower, increasingly exhausted human. Welcome back. I'm the bearded AI guy, and today we are tearing down the broken mechanics of the AI collaboration loop. Interface design is moving away from the prompt, output, accept model that defined early chatbots. We are now dealing with agentic workflows, multi-step, partially autonomous systems where AI models plan, call external tools, and iterate across long time horizons. But system architects are making a mistake. They are trying to port outdated, manual, human-in-the-loop oversight models directly into these highly autonomous systems. Treating a senior engineer like a mandatory toll booth for an autonomous agent neutralizes the AI speed advantage while maximizing human fatigue. We have concrete field evidence proving this. A randomized controlled trial was conducted by the Model Evaluation and Threat Research Group. A randomized controlled trial is a scientific study that randomly assigns participants to control and treatment groups to accurately measure cause and effect. The study followed experienced open-source developers working on their own mature, familiar codebases. This chart shows the result. Developers suffered a 19% increase in task completion time when AI tools were introduced with strict oversight rules. The immediate cause was a low acceptance rate. Developers accepted fewer than 44% of the AI's generated outputs. The workflow failed because human participants were reduced to cleanup laborers, spending their time scrubbing low-quality code generations. In this broken loop, the human's marginal intervention did nothing to improve the final outcome. The excessive oversight only succeeded in adding massive latency to the development pipeline. Paying a senior engineer $200,000 a year to act as a human linter for a hallucinating model is a poor use of capital. Human friction must be measured as a return on investment. If verification takes longer than raw execution, your loop architecture is actively harming the business. To fix this, we need to stop viewing loop depth as a binary switch between manual control and full automation. Loop depth is a fluid spectrum that must be tuned dynamically based on task phase and risk surface. Human participation should focus on 5 interventions of outsized lift. The highest leverage intervention is context injection. AI models completely lack tacit, organization-specific knowledge and historical style quirks. The human holds this privileged context. Injecting it at the right moment is the most valuable use of human attention. The second critical intervention is mid-task steering, or drift correction. A human must catch an agent's reasoning before a minor hallucination compounds into a catastrophic failure over a long horizon. Human cognitive capital is a premium resource. It must be spent on high-leverage steering, not menial proofreading. You cannot fix a broken loop by telling humans to review faster. This chart outlines the architectural solution, replacing blanket approvals with programmable workflow decisions. This starts at the top, where the AI proposes a plan and hits a goal-clarified decision gate. Oversight must be treated as a programmable policy layer. In the Anthropic SDK, a tool needing approval is an explicit, programmable event rather than a hard-coded stop.
The first half of this policy is automation. The system should auto-approve reversible, low-risk actions. The system should block and require explicit sign-off only for high-risk or irreversible actions, like a production database write. Coding oversight as a selective, risk-based policy eliminates review fatigue and ensures the human is only interrupted when the stakes demand it. To achieve true co-execution, you need a specific architectural requirement: interrupt and resume state management. State management is the software engineering practice of recording a system's exact data and progress at a specific moment in time so it can be perfectly restored later. Imagine reviewing a 40-step agent run, spotting an error at step 39, and realizing you have to restart from scratch. A stateless review process is like watching a sous chef burn down a kitchen for 3 hours when your only management tool is firing them. The technical solution is serialization using graph architectures like LangGraph. LangGraph is a framework specifically built to create stateful, multi-actor applications with large language models. This allows the system to save the exact state of a node upon interruption. This state-saving architecture makes a genuinely collaborative workflow possible. The system pauses mid-run, asks for missing context, and continues forward with the new data.
Collaboration is defined by the ability to pause, clarify, and continue, rather than stop, scrap, and restart. As workflows span multiple enterprise apps, custom state management isn't enough. This is where emerging interoperability standards come in, specifically MCP and A2A. MCP stands for Model Context Protocol, and A2A stands for the Agent-to-Agent Protocol. MCP explicitly standardizes the human reentry point for trust and safety. These protocols turn tool usage into a universally recognized privileged action boundary. In an A2A world, human oversight permissions must travel securely across agent boundaries, not just live inside one application's UI. Without standard interoperability hooks to catch an agent before it fires a destructive tool, multi-agent orchestration is a liability. We can translate this research into a deployable framework for technical leaders. This is the minimum viable oversight policy, designed to help teams instantly calibrate their loop depth. Rule 1 is the default. Let the agent run in blocks and keep humans out of the inner execution loop until it reaches a checkpoint. Rule 2 is escalate. Increase human involvement only when irreversibility, domain novelty, or regulatory risks spike. Rule 3 is de-escalate. Strip away human oversight when verification is cheap and automated, letting CI/CD pipelines and linters do the babysitting. CI/CD stands for continuous integration and continuous deployment, which are automated systems for testing and delivering code changes. Dynamically sliding on this scale is the only way to achieve both high reliability and high automation. Software development has matured past simple model adoption. A sustainable corporate moat now lives in the workflow architecture that catches algorithmic drift before it becomes institutional debt. Thank you for exploring state-preserved execution graphs. If you found this useful, hit the like button and subscribe. I'm the Bearded AI Guy. Remember, an approval gate is only as smart as the state you can resume from.